Hi there and welcome to the EHEDG Connects news update. We have some breaking news from the EHEDG certification group brought to you by Tracy Schoenrock, who is a member of the board of directors of 3A SSI and also a member of the EHEDG executive committee. Tracy, would you like to share the news with us, please?
Yes, of course, I'd be very glad to. We are quite excited about being in a position to offer a new service to the members of EHEDG. We are going to provide very early, date to be determined, but very early in the second quarter of 2020, a design tool service for evaluating the cleanability of external equipment surfaces.
Why this new method?
The goal is to, as with all other EHEDG tests, is to have the procedure standardized, the equipment, at least equipment type and function standardized, so that any of the authorized testing laboratories that wish to provide the test procedure and gear up with the cost of the robot is eligible to then offer the design tool service initially, and eventually when EHEDG is ready, convert over to an actual certification process.
You already mentioned the robot that is involved in this method. We wrote about it in EHEDG Connects magazine. Can you just explain what the process steps are?
The process is really all that difficult to understand. A sample item comes in, it is placed on a test platform, and a soiling solution, which is made up of basically condensed milk. So it's a little bit thick and adheres well to the surfaces of the test item. It is completely covered with the soiling solution in a super saturated covering, so it is fully covered and quite wet. It is then allowed to dry, and then it is placed on a platform within the robot test chamber, and the robot is equipped with a end-of-arm tool that has 3 fan sprays, and the robot then is set up to, based on the shape and size and configuration of the test item, it makes a circular path around the test item. It makes 2 passes with the full spray to see if it will wash away all of the residual soil that accumulated on the test item. And then once that is done, there will be a similar optical scanning of the test item under ultraviolet light, because the test or the soiling solution has a fluorescing tracer added to it, and so under UV light and the optical sensors, we can take very detailed pictures of all surfaces, and then the computer can, the algorithm will then evaluate the amount of residual soil overall, and it will also be able to track residual soil on individual component parts to see if one part soils and doesn't clean well on a repetitive basis.
It took quite some time to develop this method. Was it a complex process?
I would say yes. The whole process has been found to be very complex because of the types of evaluations that were envisioned and the complexity of the types of items and components would eventually be tested or evaluated under the new procedures. Nobody actually knew until we started the development, and the development of the test procedure actually went quite smoothly and quite quickly with the input of Fraunhofer.
Okay.
What was the major problem, and the one that is the most complex, is the final assessment of the cleanability.
Yes, and when it comes to assessing the cleanability of the components in a consistent way, the robot can offer a great added value, can't it?
Fraunhofer and Knut and his development committee has done an excellent job, or did an excellent job, in developing the actual robot procedures and testing and repeatability of how the robot interacts with the test item.
Yes, the Fraunhofer Institute obviously has a lot of expertise when it comes to automation, but still the robot needs to know what a component looks like. So if I want to submit a component for certification, do I also have to submit a digital wireframe with it?
It could actually operate either way. At the present time, the robot system does have algorithms built in which we can evaluate and create the shape pattern that is necessary to control the movements and circular path of the robot during either the soiling or cleaning process. That's available to EHEDG, so somebody can send in a sample just in a box, and we can still do all of the necessary scanning and creation of the envelope or wire model, as you mentioned, to conduct the test.
What are the limitations related to the dimensions of the components?
So at this point, we're talking about relatively small to medium-sized components, such as you could test the outside of a small electrical control cabinet, or you could test something as small as a micro switch, if that somebody wanted to make sure that their micro switch or control cabinets were in essence cleanable. So we can test individual components. There have been discussions about, well, if you had a complex machine, such as a packaging machine, could you test the cup dispenser, the filling head, the capper, the labeler, and test them all independently, and then get a reasonable overall picture of the cleanability of the larger assembly? That's a potential for the future, and has not yet been resolved by EHEDG.
Well, a big thank you to all the members of your group, and congratulations with this achievement. By when can the testing laboratory start to make good use of this new method?
We will have the preliminaries of the assessment, optical assessment equipment installed, and the algorithms written for the evaluation of components, and be able to offer a service to the industry very early in the second quarter of 2020.
Thank you, Tracy, for your time.
Thank you very much for the interview.
And dear viewers, if you have any questions or comments, please feel free to leave them in the comment section below. See you next time.